Okay, so we've just looked at the sine rule. Now we're going to look at the cosine rule. So the sine rule is great, but it doesn't always give us the answer to what we need, or it doesn't help us solve our problem. So the sine rule, for example, can only be used when we have one angle and the side which is opposite to that angle, as we showed earlier. So what the cosine rule, it actually begins to fill in this problem. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So that is the basis of our cosine rule, and let's show you why. So as previous, we can draw a non-right angle triangle that looks a little bit like this, and we're going to call these different sides A, B, and C. We'll put our little letters of A, C, and B, and then we'll draw a straight line down here. We'll call this, maybe put this B out a bit further out. We'll call this D, and we'll make that right angled. And what we're going to do now is we're going to use some Pythagoras. So we've shown from Pythagoras that our hypotenuse squared is equal to the sum of our adjacent and our opposite. But what we actually have here is we don't have our opposite to our A or our C. So what we could say is we're going to call this from A to D x. That would mean that from D to C we could describe this as B minus x. Okay, some brackets around there makes it a bit neater. So that means if we were to use Pythagoras, we could say that we have a squared, which would be, well, it was do it in triangle A, D, B. We can say that we have c squared equals h squared plus x squared. And likewise, in triangle DAC, we can say that a squared equals h squared plus b minus x squared, right? So now we have a set of simultaneous equations. So what we need to do here now is a little bit of rearrangement. So if we can say for our first triangle that h squared minus c squared, h squared equals c squared minus x squared, and for our second triangle we could say that h squared equals a squared minus b minus x squared. We now have some simultaneous equations. We can minus from these from each other, and we would get c squared minus x squared equals a squared minus b minus x squared. Okay, so at the beginning of our solution, so we can begin to tidy this up a little bit, where we could say that c squared minus x squared equals a squared minus, well, we need to multiply this out, so that would be b minus x, b minus x, so that would be b squared minus 2bx plus x squared. There's a negative here, so we'd put this through, we'd say that would be minus b squared plus 2bx minus x squared. That means we can cancel these two on this side, so c squared equals a squared minus b squared plus 2bx. So maybe we put this in terms of a and tidy it up a little bit. So we could say that a squared equals b squared plus c squared minus 2bx. Okay, but we've got this x and we don't know this x. So what we want to try and do is we want to tidy this up a little bit. So perhaps if we look at this triangle, we've got our x here, and we want to get rid of an x, and we want to have an a here, and we want to try and make this also in terms of the same letter. So if we were to say we have x here, and we were to write SOHCAHTOA, we need to get rid of this x. We don't want this h, and we know this C. So what can we do? So we've got this triangle, and we know that this is our hypotenuse, this is our opposite, and this is our adjacent. So we really want something which is our hypotenuse and adjacent, which is cos. So we can say that cosine of A equals, well, then we know the cosine of A equals the hypotenuse, is the adjacent, which is x, over our hypotenuse, which is c. So we can say that x equals c cos A. And from that, we now have the beginnings of the solution to our problem. So we know we've found that x equals c cos A. Therefore, we can sub this in and we can say that a squared equals b squared plus c squared minus 2b c cos A. So that is the solution to our first problem. So we can also begin to kind of tidy this up a little bit, and we can do this again a number of times. So what happens if we want to have B the subject to our question, or C the subject to our question? Well, what we can do is we can rearrange, or we can then apply to the triangles in a slightly different way. So, for example, that would give us, if we wanted to put b squared, you can do the proofs yourself, we can say that b squared equals c squared plus a squared minus 2ac cos b. And likewise, we could then say that c squared equals a squared plus b squared minus 2ab cos c. So now we have three relationships, and that means that we have all the equations which can help us solve pretty much anything we have in a non-right angle triangle. Let's give this a try. So let's think of maybe an exam style question I might ask you in triangle ABC. BC equals 7 centimeters, AC equals 9 centimeters, and C equals 61 degrees. And I might ask to find AB. So if we draw this triangle, we just draw any triangle as previous, and we can say that this is maybe C, this is B, this is A. We can begin to put our sides on. We would say maybe A equals 7. So we know our letters on, so we're jumping the gun. A is that side, C is that side, B is that side. We know that B to C equals 7, so B to C, I'll put it back again. And we said that A to C equals 9, so we're looking for our C, and we've also been told that our angle is 61 degrees. Okay, so we go back to our equations, and all we see is we want c squared equals a squared plus b squared minus 2ab cos c. That comes down there, and we just throw all this stuff into the equation. C squared equals a squared plus b squared minus 2ab cos c. So it would be c squared equals 7 squared plus 9 squared minus 2 times by 7 times by 9 cos 61. Our calculator then tells us the answer is 8.302, and then that we can round that and neaten up as an exam style question, which would be C equals 8.30 centimeters to 2 decimal places. Okay, so that's quite simple. But what happens if we want to find a angle? Well, you know this as well. This isn't too difficult or too away or far away from the norm that we've done before. So this also shows where the cosine rule is great. So maybe say if we had in a triangle A, B, C, A equals 9, B equals 16, and C equals 11. Okay, so we've got all this information, and this really shows how the sine rule wouldn't work. So we draw this triangle. We're going to call it A, B, C. Doesn't really matter which way you call that. And we know that our little c equals 11. our B equals 16 and our A equals 9. So what do we want to find? We're asked by the question to find, to the nearest degree, the largest angle in the triangle. Okay, so what would this be? So by visual inspection, we could see that that is going to be B. But if you're not sure, remember in the exam, it's possible that the angles I will draw you won't be to scale. So you might need to check a couple of them just to make sure. So we're looking for B in this case. So that means if we go back to our equations here, we want to find the one which is in terms of B, which would be here. So we can then take our equation back down, and we can say that that would be b squared equals c squared plus a squared minus 2ac cos b. So we draw that here. So we wanted b here, so that's b squared equals c squared plus a squared minus 2ac cos b. That means now we can just rearrange, we can stick in all these numbers, so we know that b squared, or maybe we just rearrange the equation first. So then we have a 2ac cos b. So this would then, well, we need to bring all this to one side, so that would be c squared plus a squared, and then we have a minus b. We bring this b over, we bring it all to equal 0. That means that then, well, this would be a negative, so we have to divide by 2ac, and that would equal our cos b. We can then stick in all our numbers, and we would find that cos b equals a squared, which would be 9, c squared, which would be 11 squared, plus a squared, which would be 9 squared, minus b squared, which would be 16 squared, all over 2 times by 9 times by 11. And that would mean that we have our b, which will give us an answer of something along the lines of minus 0.2727, which isn't wrong, don't worry. And if we then were to stick that into our calculator, which is cos b, if we then to stick that into our calculator and we were to say that b equals the inverse cos of minus 0.2727, we would see that b actually equals 106 degrees. So that would be the answer to our question. Okay, so that has been the cosine rule. Next, we'll just move on to something quickly, the final part of the lecture, which is